right, so what we're going to do is look at how to determine or how to find a value of k so that a piecewise function is continuous at x equals 5. So the reason why we're so focused in on x equals 5 is because if you look at the numerator, that part is defined for x not equal to 5, and x equals 5 is the only value that's of question here. So we're using the second piece when x equals 5 to make sure that the two pieces line up, because the first piece, as you can see, is undefined when x equals 5, and that could mean we either have an asymptote or a hole in the graph. So here's the definition. We know that a function is continuous at x equals 5 if the limit as x approaches 5 of the function is equal to the actual value of the function. And there I did it again. I put it in a instead of a 5. So let's just figure out what we can do first. So I know that f of 5, based on the highlighted yellow piece of the function, is equal to k times 5 plus 5, which is basically just 5k plus 5. Now, if I want the limit as x approaches 5 of the function, I'm taking into account that x is not equal to 5. That's what limit means. I'm approaching 5. I'm not equal to 5. So that means we have to contend with this expression right here. And as you might expect, the numerator should factor if this limit is going to exist. And sure enough, it does. So we take the limit as x approaches 5. And the factored form of the numerator is x minus 5 times 2x plus 5 all over x minus 5. And wouldn't you know, the x minus 5's cancel out. So we have the limit as x approaches 5 of 2x plus 5. And that's equal to 2 times 5 plus 5, because now we can use direct substitution. And that gives me 15. So that means the value of the function is 5k plus 5, and I know that this is going to be continuous as long as these two things are equal. So now solving for k, 5k equals 10, which means k equals 2. So that means when k is equal to 2, these two pieces match up at x equals 5. If not, they won't. And there's using your definition of continuity. Thanks so much for watching.